Hello, I would like to share my solution for this problem of organizing container of balls here in HackerRank. So basically, behind this story of balls, the problem is such that we receive some containers. So what we receive is actually a vector of vectors, so that each vector inside this vector, the main vector, represents a container. So here in this example given, there are two containers, and we can also see them in the image. And however many items there are in one container is also however many items there will be in any container in the input, because the index of the item, there are integers. Uh, the items themselves, they are integers, and the index represents however many balls there are of actually the element itself represents however many balls there are, and the index represents the type of the ball. So here in this example, the type is shown as a color. So for this given input of one array of 1, 4, and the other one as 2, 3, it means that we have one container that has one ball of the first kind of ball, which is represented here as green, and four balls of the other kind of ball, which is shown as red. Similarly, for the other container, the second one, we have two green balls in this case and three red ones. And the problem goes as such. Is it possible, using only swap operations, to organize the balls among these containers such that in any given container there is only one kind of ball, like uh, yeah, exactly, only, for instance, here only green or only red, and in the other container only green or only red. And also for any kind of ball, all of the balls of that type are in one container only. So for instance, if there are 100 containers and 100 balls of just one type, all of them would have to be in only one container, not like 50 in one and 50 in another one, or one in each one. No, it has to be all of the balls of a given type, they have to be in only one container. So after thinking a little bit about this problem here, I realized that, by the way, the swap operations refer to swapping a certain number of balls from one container to the other container. So we cannot just, like, for instance, move this green ball from container 0 to container 1 out of nowhere. We have to, when we do it, either move a green one from here to there as well, which wouldn't change a thing, or move a red one, which in this case would be a solution. Would it be a solution? Actually, it would not be a solution. Well, yeah, it would not, but you got the idea. Basically, when we swap the balls, we have to swap a certain number of balls of any kind with uh, the same certain number of balls of any other kind from in between containers. So as I was saying, I thought a little bit about this, and the solution that I uh, came up with for this problem is as such. Well, if we think about the kind of ball that has the most balls, which in this case here is red, there are six, there are seven actually, seven red balls. And since we can only swap balls, there is an invariant here, which is that the number of balls in any given container is always going to be the same. So it doesn't matter however many, how we do these swap operations here, both containers are always going to contain 5 balls. So if you think about it really, oh, actually we have to tell, and this is important, I forgot to mention, we have to tell whether it's impossible or possible to do so. So this is the key point here, whether it's possible to move, to perform the swap operation so that those conditions apply. Um, so yeah, thinking about it, if we didn't have, uh, if we did, here actually it's already impossible because, yeah, thinking about it, since you can never change the number of balls that you have in one container, it's it's intuitive that the number of balls for the type that you have the most, for instance red in this case, has to be the same number of balls in the container that has the most number of balls, because otherwise it doesn't matter if it has less. So let's suppose here container 0 has six balls. It's already and it's the container that has the most number of balls. It's impossible to move the 7 red balls to container 0 because, well, because of that. It doesn't matter how we swap the balls. We can never change the quantity of balls that container 0 has. In this case, it's already possible because it has 5, and it doesn't matter what we do here, however many swap operations and how we do, we can never get all the red balls to be here. And once we do move every single ball of the same type to the container that has the most number of balls, we can just ignore that container and work with a sub problem of this bigger problem and get the next kind of ball that has the most number of balls and compare it to the from the remaining containers, the container that has the most number of balls. They have to match, and so on. So let me share with you the solution that I was able to code here in C++ for this problem. Well, a lot of code is given, but basically this is the code is just mostly boilerplate. This is the important part, which is this function here. We receive that kind of matrix there that represents the containers, and we are supposed to receive to return, sorry, either possible or impossible. So the number of containers is however many uh, vectors we have in this containers here, this sort of matrix that we receive, and the number of types of different balls is going to be, uh, remember that every vector inside this has the same size, and it's the number of the number of the number of indices, basically the number of the size of any of these vectors. I took the first one here, assuming that there will always be one. And what I did was basically I sorted by the container that has the most number of balls. I sorted, I created a vector of integers representing the number of balls in containers sorted. So in the example case, it would be 5, 5. So this is what this code here is doing. It's simply creating initially the container uh, with the number of balls in each container. The code for this can be seen here. We have the the container here, and what we do is we iterate over each kind. And well, remember that the element there is an integer which represents however many balls of that type we have. So we just sum them up. So this is the number of balls in the container, and we create a vector of the number of balls that there is in every container. So initially it's not sorted, and we just sort it uh, in descending order, so that the first one has, it actually doesn't matter however how we sort it, as long as we sort it in the same way as the other vector here, which I'm going to talk in a bit. But we sort it here in descending order. And here comes the interesting part, which is that we do kind of like the same, but this time we create a vector of that is going to represent the number of balls of a type, of a specific type, uh, whatever it is, sorted by the highest one. So basically, what we do is we iterate over the containers again, but this time we we simply uh, we get the well, actually this is kind of redundant, I guess, because it's gonna be the same. But anyway, this code here just gets the number of balls of a specific type, and then we sort it in descending order, just like the other one. And if they match, then it's possible. Otherwise, it's impossible. That's the logic that I described it before. If they do not match, that means that somewhere, like there is a container somehow that it doesn't matter however many swap operations we do, how we do them, it's simply impossible to place the to like organize it in such a way, the way that was requested in the problem. So this is basically it. I found it to be quite an elegant solution, so that's why I decided to create this video. Possibly a bit confusing, arguably, but anyhow, this is it.